Okay, so let's look at this, right? How is it possible that I take 2p plus 3 and that's equal to p plus 9? Because now, what are we looking at? We're looking at equations with pronumerals. Now, if you haven't seen that word for pronumerals, that's just a fancy little word for a variable. And what's a variable again? A variable is...
The number. The letter.
Yeah, it's a letter that represents an unknown number. So can you see, I have a variable, I have p's here. I don't know them just yet. I'm going to find them. Momo, what's the goal of any equation, no matter what it is?
You want to get it like equal to something.
I want to get, at the end of the day, don't worry about what this looks like right now. What I'm trying to get, when I'm asked to solve, I should really say that here, solve, I want to get p by itself. That's what I'm looking for. Now, I've been kindly donated these pies here, which I'm going to have for lunch. Thank you. Let's say the p represents the weight of these pies here, okay?
Yummy.
And remember, I like a visual representation of these. So let me draw out my scale. Do you guys like that visual representation? Because I like it. You don't like it. Okay, all right. Let me just show you the visual representation. Just to get our heads around what Riley's asking here, what's actually happening here? Remember, what does 2p actually mean? It means 2 times p. So how many pies do I have? I don't just have one. I have... 2. Can I pick up the second without dropping it? I can. 2 pies. Okay. 2 pies. 2 meat pies. Right. So I've got 2 of these pies here. And I can't draw pies very well, so I'm just going to draw circles. But what else do I have here? I have 3. So let's say I've got a 3 kilogram weight. What about on this side? How many pies do I have? I've got 1 pie. 1 pie there. And how much of a weight do I have? 9. Sorry, that's meant to be a 9. It's a 9 there. 9 there, okay? Now, if I take this, now think about the goal of any equation. I want p at the end of that. I want to know how much one of these pies weighs. What can I do with this scale in order to do that? Because right now, I just want one of these. I've got 2 pies on this side, 1 pie here, all these different numbers here. What can I actually do here in order to find out what one of these pies is equal to? That's what I'm looking for. Jackson.
You can divide it by 2.
So think about dividing by 2, right? You can see that there's a divide by 2 here.
No,
But it's a bit...
actually I've learned.
Yeah.
You have to do the minus 3.
Okay, let's come back, because I've been telling you always think about operations, opposite operations. But it's a little bit confusing when there's 2 things it seems like you could do. If you go here, it becomes really obvious. Right now, okay, the first thing I want to do is I want to get rid of this 3 block over here. Can I get rid of that?
Yep.
How do I get rid of that? I have to,
Take away.
I take away 3. Can I do that first? Let's take away 3 from both sides. That's my first thing I want to do. When I take away 3, I'm literally saying, let's get rid of this block here. Go away. But in order for my scale to be balanced, what I do to one side, I have to do to the... So I want to cut a little bit of this off. What am I going to be left with?
6.
Yeah, because 9 minus 3 is 6, right? Now that I've got 2 of these pies is equal to the one of these pies and a 6 kilogram weight here, what can I do to both sides to get just the pie by itself? Momo. Can I eat one of these pies? Is that allowed?
No.
Oh. No eating in class. Let's take away one of those pies from each side so it's balanced. But what does that actually mean algebraically? What happens when I'm eating a pie? I take it away. I'm subtracting.
What if you put hand down? Back up. Oh,
So I've got, right now, 2p is equal to 6. As I said, let's take away p from both sides. What's 2p minus p? Just one lot of p. I've got one lot of pie left. What's going to happen here? If I ate one of these pies, they go away. What do I get left with on this side? 6. So what's one of my pies weighing? 6. Can you guys see that? Right? Does that make sense? So we can always check if these are right or not. How do I check? I go back to my equation. What's 2 times 6? That's...
12.
And 12 plus 3 is 15.
Yep.
And what's 6 plus 9? That's...
12. 15.
15 as well. Right? So equations always have to be balanced, and we do that by thinking about opposite operations. Okay? We always think about opposite operations. Jot that down for me. Like, let's look at this one over here, right? If I look at this one, what do I want by itself at the end of the day? The y. The y is the equation I'm trying to solve. I want that at the end of the day. What do I need to do in order to do that? Well, I've got this 3y over here right now. How do I think about the opposite of addition? It's, so what do I want to subtract to the other side?
3.
Yeah. I want to get the y's to the same side. Right? What's 5y take away 3y? 2y. It is 2y. So think about it as what you do to one side, you do to the other. It's my balancing act that I need to do. What happens after 3y minus 3y? That's just going to go away, isn't it? What do I get left with on this side? It's just 4. Now I've got 2y is equal to 4. Again, think about opposite operations. What does 2y actually mean? 2 times y.
2 divided by y.
So the opposite of multiplying is?
2 divided by y.
Okay. And so I'm saying, I know that 2y divided by 2, that's just y.
Divided by 2y.
And 4 divided by 2, that's just 2.
So that means y. There is a problem. Yeah.
And there's my answer. Is there a question about this, Jackson? Shh, shh, shh. Listen up.
No. How come, right, at the top,
Yeah.
with y's, we had to minus, but then we divided.
Yeah. So this is what we call multiple steps in our equations. It's not just one thing. You found that it's not just one thing that we have to do. It's not just one thing that we have to do. Sometimes we're adding, sometimes we're dividing. The key to knowing which one to do is you always think about your opposite operations, right? I'm always thinking about, okay, what's the opposite of adding? It's subtracting. What's the opposite of multiplying? It's dividing it. That's what I'm looking to do. And the more practice we do with these, the better we'll get at them, right? Does anyone want to have a go at this one for me? What's the first thing I want to do? If I'm thinking about the opposite operations, Momo, go for me.
Would you do like plus 3x?
Yeah, let's do that first. Let's get them all to the same side, right? Right now, this is a subtraction. I know the opposite of subtraction is addition. So I'm going to add 3x to both sides. Right? Now here, 7x plus 3x, remember those are like terms. I'm adding those together. That's 10x plus 5. So I only add it once. Okay, I'm only adding to this thing. So 10x plus 3x, that's 10x. So 7x plus 3x, that's 10x. Over here, what's 3x minus 3x?
It's nothing.
It goes away. Poof, it's gone. It is poofed. Now, what do I want to do next? What do I want to do next? Can you remind me, Blake? Opposite of addition. Subtraction. And what do I want to subtract in this case? What's the goal? The goal of any equation is to get x is equal to something. It's to get x is equal to something. So I'm saying, look, right now the x is not by itself. I'm looking for it, Jesse. I'm looking for it.
Me too.
Can I find you? I want to find you. What's the opposite? I can't see it, but what is it? I subtract 5 from both sides.
Minus 5 on both sides.
Yeah. It is. We're almost there. So we've got 10x is equal to
10.
15 minus 5, which is 10.
And then you divide.
Hold on. Remind me again, Maddie. What does 10x actually mean? What does it mean when I have a 10 and x next to each other? It's 10 x's or 10 times x, right? And so I'm thinking, what's the opposite of multiplication? Division. You guys got it. So what am I dividing by? I'm dividing both sides by 10. And so my answer, x equals to 1. So at this point, the better you guys get at doing these, the less you have to rely on drawing these. I'm drawing these now so you can see what's my thought process, okay? But you might not have to draw them at some point. And again, I want to get out of the habit of just looking at this and saying, I have no idea what this x is going to be right now. I'm just going to guess random numbers. I don't know what it's going to be either when I start this equation. But it's like going on a journey. I'm trying to find out what it is. I know in this case x was equal to 1, but I didn't know until I got to the end there. So it's okay if I don't know what it is at the beginning. I'm going to find it out. Any questions about that one? How do you feel about that? Yes, Liz.
Like when you're writing these equations up, you already like know the answer. Like, do you think, oh, I'm going to do one that equals this number, or do you just write it up and like solve it as you go?
What do you think?
Write it up and just solve it as you go.
I do a bit of both. because I want to make sure that when I give you an answer, I think you guys feel more comfortable when they're whole numbers. Would that be fair? Yeah? So I want to make sure that the number's a nice little number that you guys can work with, right? But sometimes, right, I want to keep it a bit of a mystery, and I want to work it out together with you guys, right? And I think that way, it shows that if I don't know the answer, then I can rely on you guys as well, because I know I can rely on you guys to help me find it. How do you feel about that? Good? I think that's good too. Jot those down for me. If you have any questions, please ask. That's what I'm here for.